Welcome to math class, and you have this part, that's the graph for f, and then that will be the graph for g. So that's the path, and now we're required to calculate the period of f. So the period will be let's look at the period shape. So that's a complete shape, and then that's all the shapes. So we have the second one, and then that means we have there up to there, so that's half, so that's the half part. So we check the distance, it's 135 plus 45, and then that would be 180 degrees. So that is a half period. So full period 1, which is multiplied by 2, which is gonna be 180 degrees multiplied by 2. So that's the part that so multiplying that by 2 is the full period, so that gives us 360 degrees. Okay, and then moving on to so the period there for f. So check which graph you're dealing with, because when they are combined it's too confusing. So p is 30 degrees period, and then amplitude, that's the height, so it's the max plus minimum, the distance between max and minimum. So it's 1 minus bracket negative 1, so that is a half of 1 plus 1, which is half of 2, gives us 1. So our period there, that's mean, and that is max. And then from there we get 1. So 1 is our period. Okay, so that will be 1 as our period. That's 6.2. And then write down the value of a. So if you look at a, it's gonna shift, probably shift to the left. Okay, so that means that is going to be right down there. That will be 45 degrees. So look at it, it shift to the left or to the right, depending on how the graph is. So that's 45 degrees to the left. Okay, 45 degrees. So that's 45 degrees. And then from there we look at also the values. Now I'm getting to a 6.4. Okay, so 6.4, without the calculator, but we're just going to use a calculator to confirm something. So we have sine to x is equals to k, and then we know that at k, what is the value? That is negative 75 degrees. So we look there at the value at k, and then finding that is negative 75 degrees. And now all you need to do is substitute that value there, and then that will give us negative 75 degrees is equals to k, and then 2 times 75, that will give us negative 50. So it's negative sine negative 50 degrees equals to k, and we know that so that will be minus sine 150 degrees is equals to k. And using the cast rule, we have sine there, and then we have 180 degrees, and then from 180 degrees minus since 150 is 180 minus 30 degrees to give us 150. So that means we have, okay, those are the coordinates, so that's going to be negative sine 30 degrees is equals to k. So already if you are used to the special triangles, you know that the k is negative half, but let us sketch up everything. And then 30 degrees using sine coordinate, so opposite of hypotenuse is 1 over 2, so we have negative sine 1 over 2 is equals to k, and therefore we're done. We're looking at 6.5, which the values are the same under those coordinates, and then you check there from the graph. So the graph will mean that, okay, we have x, x is equals to negative 45 degrees. Okay, so that should actually be the shift. From there we have 45 degrees. So from there we have moved to this last equation. So the one to prove without calculator, determine the number of solutions of the equation. So sine x plus sine x plus cos x, root 2 sine 2x is equals to sine x plus cos x. Then we know that, let's substitute and see 4x is equals to, let's say, 45 degrees. So we go there, why 45? Because that's where they meet. And then on that interval, so that's the interval we have from negative 90 going straight to positive 90. So that's the only part that meets. So I think we only have one solution there according to the graph between those 2 points, negative 90 to positive 90. Now with that information, we have to prove that it's really equal. So we substitute. Let's say we have root 2 bracket sine, so that's 2 times 45, okay, is equals to sine 45 degrees plus cos 45 degrees. I'm sketching out the graph spatial angle. We have 45 degrees there and 45 as well, and then we have the rectangle, we have root 2 1 1. Now we can go and say sine 45 degrees, that opposite of hypotenuse, 1 over root 2, and then multiplying 1 over root 2 by root 2 over root 2, that gives us 1, doesn't change anything, so that's going to be root 2 over 2, okay, because root 2 times 2, root 2 is going to be 2, so cos 45 degrees will be the same thing, adjacent of hypotenuse, and that's going to be 1 over root 2, and that gives us root 2 over 2. So that's it. And then now we have sine 90 degrees. So sine 90 degrees, okay, it is 1, just to prove the calculator, that is 1. So sine 90 degrees will give you 1. So we don't show the way, you don't use a calculator, so it's gonna be 1 there. You have to know that sine 90 is 1 and cos 90 is 0. Okay, so substituting all the values, root 2 over 2 plus root 2 over 2 is equals to half the root 2 times, half root 2 times 2. So that means that it's the root 2 is equals to the root 2. So the left hand side is equals to the right hand side. So it's proven, and there's only one solution so far between those interval. Thank you for watching, and don't forget to follow or subscribe on Twitter, Black Adam. Thank you.